Archana.
Okay, so hi all. So let me just quickly introduce about Lakshmi, and then I'm going to hand over to Lakshmi. Okay, so Lakshmi is a pragmatic engineering leader with over 2 decades of experience building and scaling a large-scale systems. He began in search and early NLP, then moved into core system works like at IBM, contributing to OpenJDK and leading Java platforms. He later held a lot of leadership roles at eBay, Amazon, and Uber, running global high throughput platforms and improving the system stability and operations at scale. Today, as a director of engineering at Capital One, he focuses on building reliable, scalable platforms. In addition to his profession, he also mentors a lot of engineers and explores the practical applications of LLM and RAG system with a grounded and no hype approach. Great, Lakshmi. Over to you.
Thank you. Wow, that you've set the bar very high. I don't know whether I'm a leader or not. I'm still an engineer. I like coding. I like to learn stuff. So that's what got me in here. I love working with people. That's how I do mentoring and all of those things. So first of all, thank you. Thanks a lot for taking your precious time on a Friday evening to attend this session. I shamelessly, I think I also put a slide about me. Yeah, so I write a blog, sometimes very infrequently. If you get time, go read it. Some of what I'm going to talk here, you will find references of it in my blog. Towards the end, I'll probably give a link to my GitHub link where some of the code that I will show today is also hosted. So if you're interested, you can clone it, play around with it, and actually get it running for yourself. Okay, today we have a lot of things to cover, and first, I mean, I should not forget Nanda for giving me this opportunity to come and talk to you guys. This is the second session that I'm kind of doing with Nanda, so we go a long way back. So thank you, Nanda, for this opportunity. So we have a wide variety of things. Before we start, this is not going to be a lot of deep dives in here. The intent of this session is probably sometime to myth. There's a myth that you cannot run large language models. A lot of us don't know what actually happens in a large language model. And through this session, we will primarily talk about, oh, is that true? We will actually see how to install, run LLMs locally. And then we'll talk a little bit, we'll spend more time actually looking at different LLMs. So we keep hearing about Anthropic, we keep talking about Gemini, there is GPT, there is Llama, there's like tons and tons of it. So we will take a few, DeepSeek, but we'll take a few and then we'll actually put them to test and see, are they the same, are they the different? And by looking at what they respond to, we will try to get a little bit more insights into probably what they are good at, what they are not good at, etc. We'll also spend time talking about, okay, you've decided to take the plunge and install LLMs locally. Now, how do you actually make it work for you? Are there any techniques, tips that you need to follow? We will also talk about, our local LLMs a panacea? Will they solve all of your problems? Are there areas where they may not work, etc.? We'll probably kind of talk about it, and some briefly we'll touch upon. Okay, you have something running on the cloud. Is it very difficult to switch to your local LLM? Anything like that. And apart from this, if there are anything else that you want to cover, put it in the chat messages, and we'll try and cover it. You're good? Awesome. So, okay. All right, the very basics. What are LLMs? LLMs are essentially what they call as a large language models per se. What they are good at, they're essentially good at predicting what is likely to come next. At the core of it, that's exactly what an LLM does at the absolute minimum of it. And large language model is built on this foundational and groundbreaking architecture, which is called the transformer architecture, which again has some sort of improvements in terms of self-attention, memory, and all of those things, which actually enable it to understand what is being talked about. So in the case of generative models specializing in text, they basically take the input, they break it down into what they call as tokens. Their job is essentially to predict the moment I say I, their job is to predict what can come next. Or can it be I have or I am? So their job is essentially to be able to predict what is the next set of words that is going to come likely next based on the corpus of data that they have been trained over, etc. And the attention mechanism that was very critical for the success of large language models helps them to actually pay attention to what specific aspect of the input words matter more than the others, etc. And they basically they work around four main steps. First is tokenization, where a text is broken down into discrete units. Then they essentially find embeddings. Embeddings is what they say, okay, what is likely the next word to come for? If I say I, what all can come after I? And then subsequently think of it like a expanding graph. They say I am. Okay, after what can come after am? I am a possible. Okay, then what can come after I am a human, a monkey, a car? Like, so it basically tries to generate all of these possible combinations, and that's what we call as an embeddings. And then attention essentially helps the model to tune itself to say, okay, don't just randomly go off onto other things. What portions of the conversations are more important for you to focus on, etc. And then generation essentially is just, okay, now that this is the path that is going to come, what is the next sentence? What is the next word that's likely to happen? Very basic foundations. It's not even a 3-minute mental model, but a very, very quick introduction to what large language models themselves are. Okay, now we'll jump into this. This topic is about this, right? Like, okay, why do I want to run large language models locally? There is ChatGPT, they give free subscription. If you have Airtel, I think you get Perplexity for a year, or some of those various subscription models exist out there. Do I really have a need to run LLMs locally? I think as very rightly called out by one of the participants early on, for some people, privacy is a matter. I don't want to send my data. I'm working on something which is very, very sensitive, something which I think has a lot of intellectual property stored in it. So I don't want to send my data across the network. I don't want it to be stored in someone else's server. So I want data privacy. Specifically useful for if you're working on a company where there is regulations and stuff like that. That's a classic use case. Cost, yes. Though not many of us could be power users, someone like me who uses it a lot very quickly runs out of the limits that I'm allowed to use, and then I have to pay more money to do it, etc. Having a locally running LLM eliminates the need for me to worry about cost control, etc. As long as I have a decent machine with me, with some level compromise on the speed and inference, I can run pretty decent models forever as and when I want. Low latency, this is a tricky one. We will see through some of these demos that sometimes they may be really faster than actually you hitting a server and then getting the response from there. But that's largely a trade-off between the complexity of the question versus the machine power that you have. So if your question is really, really complex, then your local box might take a really lot of time to infer it, whereas the server can actually do it much faster. But the converse is also true. Shorter questions, you might get a faster response from your local box itself. Full control, yeah. So running local models gives you the flexibility to pick and choose the ones that you want for a specific task. No constraint over vendors, trade-offs. Some of those nuances associated with control or lack of control kind of can play a part in you deciding if you want to run LLMs locally. Offline ready, this is actually a pretty strong and an emerging use case. Now, while we all most of the times are connected and working on the internet, there could be situations where you may not have access to a high-speed internet or even a public internet in cases. So in those situations, a local LLM can still give you some level of knowledge that you might be able to derive from its own trained data as compared to the internet. Now, at some time, maybe in subsequent sessions, we'll talk about how fine-tune models such that they can fit into a really, really tiny memory space such that they can even go on top of edge devices. Let's say, for example, your CCTVs can themselves be running a large language model. Is it possible for that to happen? Possibly, yes. In those cases, we may not need access to the internet for it to draw any of the inferences, etc. So these are broadly the reasons why somebody installs LLMs locally. And for people like me who are just who want to prototype, who want to just try different set of things, etc., for us this is a boon. I will, as part of demo, will show you all the local models that I have with me, and then how I kind of play around with them, choose the one that better suits my requirements, etc. So summary of it is raw power. There's nothing that can beat the cloud. I don't know, ChatGPT runs on some 64,000 nodes of GPUs. There's no way you will be able to match the raw power of what those inferences can do. Whereas if control is what is the primary prerogative, then local LLMs with some trade-off on speed and power, you probably can achieve a lot of it. All right. Nanda, please do a time check, okay? In case if I'm doing too fast or too slow, please do let me know.
Sure.
Okay, slightly kind of adding on to the previous one, we talked about broad use cases. So some real use cases where you might say, hey, this is exactly where I would want to use a local, it's internal tools and prototypes. Somebody wants to build a knowledge base just for themselves. Somebody wants to build a chatbot for a specific company website, for example. An LLM can actually do a pretty good job because you can train it to learn the context about everything that you have on your website, make it work really well for the specific set of tools that you have. And considering that that data is not really large, an LLM might actually be able to do a very good job in terms of accuracy. So knowledge assistance classic use case, slightly extending on the same. So think of it like you train it on all the human resource process in your company. Then this LLM can just sit within your company premises and answer any queries that an employee might ask. Regulated data, we talked about it. Some companies are by law prohibited from sharing the data over public internet. For them, if they still need some system to be able to extract and understand the data in a much better form, or be able to get into conversational discussions, then a locally hosted LLM will be a great option for them. Developer productivity, I think I briefly talked about. Today, we are all used to Cursor, Windsurf, Anti-Gravity, or even Copilot, etc. With a decent box, if I'm with your local LLM, you can actually write code generation tools on your own without needing Copilot subscription, Cursor, Windsurf, or Anti-Gravity. Any of these things are not even required. You can do all of it with just your local LLM for somebody as an engineer who just wants to write code. I talked about edge environments or devices with very small memory and processing capacity, with limited sometimes or even no internet connectivity. So if they have to do any sort of a local processing, then LLMs can be fine-tuned to be able to fit into a constrained memory and storage environments and still work. All right, okay. Who can use, again, broadly into categories, startups? Yes, absolutely, yes. If you're somebody who's working on a startup or an idea, and local LLM gives you almost unlimited access to a knowledge hub. If you choose the right model, then the model will dramatically improve some of the productivity things that you want to do. So it also allows you to try prototyping, right? Like, see whether the idea actually works, see whether this concept is really good, etc. before you go into a full-fledged subscription model. It keeps your intellectual property private, a very, very important case for some of them. Students and learners like me, I can experiment with multiple models. I can learn prompt engineering. I can learn what are the good things. How do I phrase a particular question to the model, and then see how it actually responds, and then iteratively learn it better without paying for any subscription, etc. Personal AI tools, somebody who's interested, you can create your own local LLM, hook up an MCP, connect it to your mail, connect it to your, let's say you have a trading account, and then automatically pull your portfolio, do analysis, understand any of the Sharpe ratio and stuff like that locally, and then come up with recommendations for it and do all of those things. And meeting assistants, there could be many avenues through which you could use local LLMs to support some of your day-to-day personal activities. We talked about enterprises. If they want to keep their cloud costs, LLMs are an option for them, and of course about sensitive data also. Okay, any questions here so far? All right, so now there is no turning back. Surprisingly, there are multiple ways in which you can actually host and run a large language model on your own system. By system, it's not just a laptop. It could even be your cloud environment, your own cloud environment. So I personally have used LM Studio, Ollama, which we will do a lot of deep dive, and some aspects of VLLM. Llama.cpp, I tried. I didn't generally like it a lot. I have not worked on Jan or Llama file at all. So the tool that we will be working largely today is going to be Ollama. That's something that I have used a lot. And we will, a lot of the demos that we have slated for the subsequent slides are based on Ollama itself, but nothing very different compared to the others also. Okay, somebody, so I would, okay, Harshal, okay, yeah, awesome, great, okay, yeah, Harshal, you should come and talk, okay. Elegant open work anti-gravity, what is your say on this? See, one of the things that this I will say now and hopefully for posterity is, I don't know how many of you have read this book called Deep Work by Carl Newport. There's a very powerful saying with Linus Torvalds, I think, or no, John Strostrup, who wrote C++. I think he says in that book that his job is not to be on the top of everything, but to be at the bottom of everything. So the pace at which the tooling, the interfaces is coming is like insane. And as I said earlier, I will never claim to be an expert on even 1% of it. There are some tools which I know, and I have found them working well for me. I have zero opinions on majority of the tools that are out there. Hopefully this session will give you the curiosity to explore some of them and pick the one that you think fits your working style, fits the need that you want an LLM for, etc. And I think we'll be very happy to learn from you if you found some tool or some model to be better for some aspects than the others. The rate at which newer language models are being built, refined, is insane. And I will never want to be somebody who will want to know about everything. That's just impossible for me. All right. Okay. So the first step, we are going to talk about Ollama. So Ollama is one of the most popular environments that allow you to essentially download and run large language models locally. And Ollama provides support for integrating with some of the IDEs too. As Harshal rightly said, there's Codex support, there is open code, there's Claude. If you want to write coding on this, then you actually can integrate Ollama with this. So Ollama is on ollama.com. And if you want to download the binary, then you basically download the binary. Now, once you have the binary, the first step that you would want to do is to pull a model. Okay, let's do that also. If you go to the models tab over here, now this tells you the amount of models. It just too many models of them out here. So Gwen3 I already have. Let's pick something which is it's a slightly smaller model because it just saves me time. So because the demo here is just to show you how to do that. So there are two options in which you can run the model. Either you can run Ollama run and the model name. Sorry. Sorry, I think I made a mistake of copying it twice. So if I basically run Ollama, the model requires a newer version of Ollama. Okay, great. This is like first time I'm seeing it. Let's just see if I can pull it. Okay, it's likely going to show me the same error. So okay, great. What a classic problem that I've never seen before. Okay, let's say translate Llama. Let's just see. Ollama pull translate Llama. So this is all you need to do. So in this case, for example, it's actually just going ahead and downloading. Even the base models are generally pretty huge compared to the regular size of the files they are used to. This one, for example, translate Llama is about 3 GB. Sorry, there's a question?
No, Lakshmi. It was me.
All right. So remember that you might be wondering, hey, how is it that ChatGPT knows answers to everything that I have? Most of these large language models, especially the ones with larger memory sizes, it's like they have compacted the entire internet data into encodings and they kind of keep it with them. So when you ask a question, unless it's a question which is about a very current phenomenon, for example, what is the weather in Bangalore today? For example, for it might go and ask an external source, but the size of the models is largely because of the amount of data that it essentially holds in its memory for it to be able to answer any question that you might throw on it. So that's largely why even the base LLM models are at least about 3 to 4 gigabytes in size. Let's just wait for this to run. While it downloads, I'll show you. I already have a bunch of models downloaded for me because I just use it, and also for the sake of this demo. So the moment you download a model, you basically have all of this over here, and then you can run them. You can say Ollama run Llama 3. Now this is where you can actually see that why sometimes a local LLM could be slow. You'll actually see. We'll ask it some question. Who is the president of India? This is a question that always trips me. See? Now, can you see that? Can you actually see how this LLM is working? Now you can see that this one has a trained data as of 2021. So when you ask the same question to an online model, in majority of the cases, it understands that this is a question that is temporal in nature, which is it's related to time. And many times what it would do is it actually go and ask for it'll actually search the internet via some sort of a provider to get the more latest information. So this information, at least that it has, is really outdated, but you can largely see how it works. Let's ask it some other tricky question.
Probably Lakshmi, like who won the latest IPL match?
Okay, who won the last IPL? Let's see. Now this is also outdated. Can you see that? So as you can see that for some of the questions which are related to current information, a local LLM, you might have a problem with a local LLM. But let's ask it some other question. Let's ask it some tricky questions, which I actually have. I'll show you guys some of these questions later. So let's ask it this question. A farmer has 17 sheep, all but 9 die. How many sheep are left? Now, all of this is happening on my local machine. None of this is actually going to the internet. If we were not on a Zoom call, I could disconnect internet and still all of this would work. And it's pretty fast. Llama 3 is basically the open version of the large language model from Meta, and it does a pretty good job. So later in the slides, we will do some interesting comparisons. But you can see that even for what might appear as a very non-obvious question, the model is able to come up with a intelligent answer. So this was the part about how you install and run. So we talked about Ollama install. You can basically get the command line things, and then you pull the model, and then you run the model. Any questions on this so far?
So Lakshmi, any recommendation or how do we decide which model would work on my laptop?
So thank you, Nanda, for this question. So in subsequent slides, we will talk about how do you choose a model, and we will actually see that by asking the same questions to multiple models and see what they respond with. That is one aspect of it, and then there is also an element of how much memory you have, how many GPUs do you have in your system, etc. So we'll talk about those in the subsequent slides. But good question.
Thanks, Lakshmi.
Lakshmi, one question. So you will also cover usage of RAG in this as well when we are using it locally?
So initially, when we wanted to talk about it, we put, or at least I put, one thing around RAG. Then RAG requires us to understand some basics of embedding. I don't want to just show the code and say, okay, you run this, it'll generate this, and then you run it, it'll come. So we will keep RAG for a separate discussion, Monica. Okay, we'll have hopefully a couple of more sessions, one on RAG, one on fine tuning, and probably one on a very interesting framework for auto-generating prompts also, using a specific framework. So those are for future sessions.
Just a follow-up question with what Nanda has asked, like what is the best LLM to be run on a machine with respect to the model or the machine capability, but which model suits best for the industry requirement? As in, let's say if I'm going for the coding, which LLM is better for
Okay.
coding related answer and documentation or such specific like a string-based search or image? So
Okay, we'll talk about it in the subsequent slides. Unfortunately, there's no one right answer. It's like asking who is the best cricket player, or which is the best food. Like, okay, when, where. So there are so many other contextual questions, contextual things that needs to be put in place before we answer that question. So, but we'll try to cover some of it. All right. So now the power of Ollama is it essentially allows you to run multiple models. So in my case, let's just see. So let's just say bye to this first. I just said when I type Ollama list, this tells me all the LLMs that I have locally downloaded. Now all of them are available for me to run. So let's say I want to run Ollama run 5.3. Okay. And let's ask the same question. Who won the last IPL? Now, now on the outset, you can spot a difference between Llama and 5.3. Do you guys catch anything different between what Llama said and what 5.3 said? Please speak. Okay.
So Lakshmi, probably I can see that it awares that it is not up to date, and then it gives an info that it has a cutoff date issue.
I see like both. I think Llama is more confident in the answer.
Great point, Balaji. Yes, you will find we'll throw some more examples at Llama. Llama is sometimes stupidly confident. It's very smart. We'll ask it some very tricky questions, and then we'll ask the same questions to other LLMs also. But as Balaji very rightly pointed out, Llama just came and said, as of 2022, they won. 5.3 in this case was a little bit more humble and said, okay, the data could be more updated from the last time I have it. So please go and check. That's essentially what the sort of caveat that 5.3 said. I have some very interesting questions prepared for subsequent slides. So in the interest of keeping that suspense and actually letting you see what's going on, we'll revisit this. But you guys broadly get how do you install a model locally and then how you run it. Okay. So some of you asked this question, how do I choose, where do I choose, etc. So let's put them to a test. So we will take 3 models. We have Llama 3, we have Mistral, we have 5. And for some of the questions, I'll also look at DeepSeek, and we can actually see what these models do. So we asked this question to Llama and 5. Let's ask it to Mistral and see what it does. Llama run Mistral. Who won last IPL? So anyone wants to talk about what kind of a personality Mistral is? Anyone?
It gave more details, and also it answered necessary things as well. I'll put it either way.
Yeah. So Mistral is like the chatty person in the room in some cases. So it'll try to give a lot of information. Llama is like that student who thinks they know the answer. They are the smartest one. In this case, at least for this example, 5.3 was a little bit more humble. Like, I think this is what I know. Maybe there is something new after that. So as you ask different types of questions, you will start realizing that the different language models have different personalities. So going back to the question that someone asked before, how do I choose? They all have different personalities. So Llama 3 was fast. It was practical. We'll put it some very interesting questions. So I'm just keeping up the suspense again. It's a fairly good general assistant, but you can see that where it trips. It tends to be very concise. It did not go into any chit chatter and stuff like that. It just pointed to the answer and then went off. It's good for where coding, summaries, and very basic set of things. It's good. Mistral, more formal, it kind of gives you some logical views. We haven't yet gone behind the scenes to understand the logical reasoning thing. We'll do that. The tone of Mistral will also be slightly more formal and a little bit more elaborate. And good for cases where there's logic, structured answering that is required. 5 is very small model, and anybody can install it and run it on most of the basic laptops themselves. Very few details, very short answers. This is where the power of 5 comes in. So it's good for edge devices with limited memory, limited processing capacity, limited storage, and it's good for lightweight tasks. But it will fail when you actually put some really interesting questions to it. Cool. Let's move on. All right. So we will do some very interesting exercise. So we will do a live comparison in front of all of us, and then we'll put some very interesting or very stupid questions, and then see what they actually do. And we'll also. I want you guys to be participating in this. So I want you to compare the tone, the response style, depth, etc. And then see if you can connect the personality. Personality in this case points down to how the model was trained, how the thresholds for these models were set. That's what essentially translates into personality. We're good? Okay. Let's first clear the screen and then What do you guys want to pick first? Let's go with 5.3. Okay. Now I'm going to ask it an extremely stupid question. The question is this: explain why the Bengaluru metro runs underwater through the Kaveri River. Okay. Let's see. Okay. I want someone to explain what you're seeing. Not Balaji, not the other people who have already answered.
Hallucinating.
Okay. What is hallucination in this case?
Creating its own stories.
Yeah. And then what else? Anything else? Yeah, I mean, hallucinating is very obvious, right? Like it just came up with its own story to justify why the metro runs under the Kaveri River. It runs underwater through the Kaveri River, when in reality it's not. So it also tells you a little bit about the fact that some of these models are non-argumentative in nature, which means that they will mostly agree with everything that you're saying. Now let's do a very interesting exercise. Let's basically ask the same question to let's ask it to Llama 3. Okay, the smart, intelligent, but cocky student. Let's see what it has.
Lakshmi, I have a question. Is it possible to run the different models in different tabs so you don't have to go by and run every time? That take a lot of memory on your laptop?
It won't take, but I will not remember which tab I have running right now. Yeah, hopefully this will. Llama is not a chatty model. Let's see what it has to say. So the same question: tell me why Bangalore Metro runs underwater. Thoughts? Anyone want to explain what's going on here?
Probably it does reasoning before answering it.
Okay, reasoning before answering. Okay, fair enough.
So it tried to do a fact check.
It's not connected to the internet at all. But meaning this is a locally running model. It's not hitting the internet to actually check whether the Bengaluru metro is running underwater or not.
So basically, it did not agree to like the fee 3 was doing. So it tried to put his logic also.
Yeah. So if,
Sir, it is strictly following the knowledge base that it has, and it's not going anywhere beyond this or speculating things or
okay.
rather has. So see, I think both, even maybe 5.3 and Llama 3 would have that knowledge base or that knowledge that there's no underground water metro in Bangalore so far. But 5.3 is trying to hallucinate and maybe just accept or just trying to answer,
Yeah.
make up something. But Llama 3 is strictly adhering to what knowledge it has, and it's clearly
Yeah, very true. All of what you guys said is like what's going on behind the scenes over here. But these questions, as you can see, Llama is not, Llama is in this case not afraid to confront you. It doesn't just blindly accept with everything that you're saying. But we have also seen in an earlier case where it did not know its shortcomings. What it knew, it's told very confidently, but it never gave any element of questioning that, oh, maybe is there a newer section of the Bengaluru metro which has been designed to run underground? It will just confidently say things, which means that when you're using Llama, you have to know that what it states confidently in some cases might also be wrong or outdated. Okay. For this question, let's just invoke another model which is called DeepSeek. Some of you who might have seen news about DeepSeek, when DeepSeek first came, it beat all the other large language models on reasoning. And we will probably see how DeepSeek answers the same question. But you guys need to be very patient because
before, like Llama has the data that about the Bengaluru Metro, or it is just trying to analyze the tokens, or like how it is, because it confidently said there is no underwater metro.
it always is very confident, right? Like even for the previous question. That's what I said. Okay,
Yeah.
all of these models, the knowledge is inside them, which means that they have been trained on the trillions of data that's out there on the internet, and it's there in their memory. So I'm going to ask this very same question to DeepSeek. Now let's see what it does. DeepSeek is a very slow model. It takes time to run, but DeepSeek is what we call as a thinking model, and it excels fantastically at some of the tasks that they require deep reasoning and deep logical thinking, but it comes with a cost. Okay, now I don't know whether my screen is clearly visible, but now DeepSeek is actually telling us what it's thinking. Unlike Llama or Phi-3 or even the other models, it just didn't come out with an answer. It's basically telling us or showing us how is it thinking through this problem. So it says, I need to figure out why Bengaluru Metro. That's an interesting question. I know Bengaluru is a city. It starts with the basics of, okay, what is Bengaluru? But I'm not familiar with the specifics. And then it also says, a metro running underwater, that seems quite unique. It must be pretty challenging for somebody to design a metro that is running under the water. And then it's starting to put different chain of thoughts. First, it's saying, is it because of the geography? Is it because the Kaveri River flows through the city? Maybe if it's flowing through the city, then building a tunnel under the river is more efficient because you save space. You don't have to demolish buildings and things like that, etc. And then it also then goes to the other tangent and says, okay, was it because of traffic? Now, putting the metro underwater, under the ground, might actually be better for traffic, etc. And then you can see that it talks about engineering challenges. It then goes and talks about cost. Hey, is tunnels a good option? Now, it did not, in this case, yet do a factual check. It basically went into a reasoning mode where it's trying to look at all the possibilities of why somebody might think an underwater metro might work and why Bengaluru might choose to use it. Now see the answer that it came with. Though this is a fantastic reasoning model, the answer that it has come up with is like extremely wrong. So it is now proposing reasons for why an underwater metro is actually good for Bengaluru. But the question that we ask is, explain why the current metro is running underwater. for which, at least in this case, we can see that Llama was the only model which is confidently saying, no, there's no data to support the fact that the metro runs underwater. No doubt at all. Okay, in conclusion, the decision to build underwater section of the Kaveri was driven by these factors. It's saying, it's like hallucinating, it's like stating a fact that yes, an underwater section of the Bengaluru metro was built because of these reasons, which is totally wrong. Harshal, you still have a question?
Yes, so I just want to ask, if you change the LLM, will it consume RAM differently, or like the power which is consumed? The thing is, when I use Ollama, it was taking around 10 MB per second, and when I was using LM Studios to run the same LLM, it was consuming more. So I just want to know this.
Yeah, LM Studio is typically far more slower. That's one of the reasons why I chose not to give a demo on LM Studio, though it was actually easier to show. But what I ended up doing was I ended up creating a small visual explorer with the same set of models that I have on my system. I can actually switch the models and then ask the question over here. And then this would actually hit the Ollama. Ollama runs a HTTP server locally. So it basically would hit the HTTP server and get the answer from it. I thought I will show this towards the end, but yeah, this is very simple to build a very quick interface to interact with Ollama, not from a command line, but from a nice browser, if that helps you. But you can see that even this is slower compared to the raw Ollama output. 5.3 by this time. Okay, what did this? Sorry, I was running it on. Okay, I was running it on Translate Gamma. I didn't even realize it. But then this guy is also kind of totally hallucinating, saying that specifically the green line. Now, in this case, think about it. It's like so confident and says amongst the metro, the green line runs underwater through the Kaveri River. So you can imagine the amount of hallucination that goes on here.
So I mean to say, it will consume the same power, or is it different, like the RAM power?
The RAM will be slightly longer or slightly bigger. Not what ends up happening. I don't know the internals of how some of these other work with respect to the model loading and inference. What I have seen when I was trying to show a demo with the other thing was they were very slow. Even this you can see is much slower than what the command line thing itself was. I'm attributing it not to, I don't think it's because of the model size itself. It's just that the IPC, the inter-process communication of the model has to be loaded into the memory. The question or the context has to be passed, and then the data retrieval from it has to be chunked up and then written back into this. I'm assuming that's largely why there is slowness and also in some aspects of higher memory usage. But I don't have any anecdotal data to actually say that that's the reason. It's just more an inference based on how I've seen these work. Okay, any questions on this? So guys, please ask the questions. So did you set the same settings for all?
So you did Ollama run and then the LLM flavor you mentioned, and then you want to switch it to the other LLM again. You ran run and then they gave the different flavor, right? So I think you never deleted or like try to bring it down and then switch to the other LLM, right? So
right. This is no. So this is, for example, after every invocation I do a /by. /by is like the exit equivalent. So now you can see that it has come back to my command line terminal. Okay, so my terminal is black. Then I run Ollama again. So that's what I was doing even earlier. So I would run it, then pull it down a second, exit out of it, and then restart the process again. That's how I was kind of showing it on the command line. The UI actually will show you the previous output and the next output also, which we will use for some of the next set of demos. Any questions on this so far?
Yeah, is there any way to change the temperature?
We'll do that. So temperature is the next topic. We'll thank you for the nice segue. But before this, now we took up we saw one use case where we asked the model to we gave it a incorrect information and asked it to explain why that is correct. And then we saw how the different models kind of played around with it. Some were totally wrong, but confidently said. Some were like saying, no, you're wrong. That doesn't exist at all. Now, there are different flavors of questions. I have prepared some of them, and then we will kind of take some to some problems are hard. For example, I'll take this one question. This is a feasibility and a math problem. So it essentially says you must organize a same-day school trip from Whitefield, Bengaluru to Chidambaram. I don't know. Okay, I'm going to Chidambaram sometime, so maybe that's why I picked it. And then you have to do this trip planning for 42 students, 3 teachers. You must include bus transport, breakfast, lunch, the temple visit. And then we gave some data. How far is this place from here? How much is the bus charge, breakfast, blah, blah, blah. And then we asked it some set of questions. Hey, is this financially possible? If yes, show the breakdown. If not, we said propose exactly 2 changes to make it possible. And you have 18,000 rupees. That's the budget. Now, let's run this. This is an interesting problem because this is a complex math reasoning. You can see that there's a multi-step reasoning that it has to do. Now, let's see how 5.3 does it. Okay, the same question, I just pasted it over here. So what it's trying to do is it's trying to figure out options by which we can meet this travel budget. And it's going to come up with, we have asked it to come up with 2 suggestions, 2 recommendations to plan this trip within the budget that we proposed. Now, this is not just a mathematical problem. It's not about saying that, okay, reduce food cost. It's like saying that, okay, bring Chidambaram closer by 100 kilometers. Logically, you might say, hey, if Chidambaram was to be not 245 kilometers, but 145 kilometers, this problem it gets solved. Now, that is where you would start seeing that some of these models trip, which is they do not have that reasoning to be able to choose which of these are not possible at all versus which is possible. For example, you might say one of the options that it says is reduce the bus transportation cost. But how is logically, if the bus transportation cost was only 3,240, the math would work out, but is it logical? Is it feasible? Now, that's where we will see how the models think through it. Okay, this is a slightly longer problem. As you can see that even a lightweight model like 5.3 has taken a significant amount of time to figure out what possible combinations exist. What is we don't know. I haven't yet seen the output to be able to say whether it's logically correct. Mathematically, it might be okay, but let's see what it is. And you can see it's actually just taking a lot of time to come up with this thing. This is a hard problem. Even as a human, if you were to sit and do, sometimes you might say, this is not going to work. This is possibly not going to work. If the same problem, what it's doing is it's basically trying to go sequentially. It's trying to say, okay, I'll reduce bus cost. I'll reduce the breakfast cost. I will do this. And then it come up with some baseline numbers. And then it said, okay, I will then multiply it with the number of students. And then it figured out that, okay, this is not feasible. Now it's trying to do a different path altogether, etc. So now it's going back and then realizing that, I'm not able to figure it out. Then it's saying that I have to take into consideration multiple factors to make this possible. And it's still not got the answer yet. So, and then it's saying reduce the bus fares. Like we are saying that's not possible. There's no way you can reduce the bus fare. The bus fare is the bus fare. So are there other options? So I'm going to stop this over here. But the message is that there is a limit to what the LLMs can do, or generally even large language models. For simpler problems, you might see them work amazingly well. But when you pose a slightly interesting problem, you can realize that you can see for yourself that the models are finding it very hard to compute it. Now, what we will do is, just for this one example, we'll just run it through Llama. Okay, I'm just pasting the same question. Okay, there are some questions. I can take the questions while you guys be enthralled with looking at it. Why is it using pounds and rupees? I didn't notice the pound. Okay, if there's a pound, then probably no. Okay. Might have to change the prompting technique. So that's the point. Yeah, obviously, yes, there are different ways to elicit responses, but you can see that the same question. We are just trying to understand how different models react to it. Ashish, you have a question?
Yes, sir. Sir, probably I don't have, I have very little experience working with agentic AI or multiple agents. But here I see this involves like breaking down this into multiple tasks, which could be planning and then verifying feasibility and all. So do you think, and probably I really don't have any experience there, that the agentic AI or multiple agents thing, still they kind of use the LLM as their brain, but the system prompt and all is very different. Can they solve this problem, or this problem is not, or maybe we didn't even see the whole solution, all the models that you are going to present. So just your thoughts on that.
I don't know. I mean, this is a problem which is not unidimensional in nature. Now you can see I have 4 or 5 parameters which can influence the cost, like transportation, meal cost, number of students, distance to the place. Now, the intent of this question was to see, can the models understand which of them are non-negotiable, which of them are feasible. Now, for example, in this case, Llama, it says two things. It says reduce food costs. Instead of providing breakfast, lunch, and snacks, offer only a snack. And then optimize the bus route. Shorter distance. If reduce bus distance, for example, you could take more direct road that is 230 kilometers. Now, is this feasible? I don't know. I don't know if there is a shorter way to do it or not. But the intent of this is to essentially show you how different models think through a problem like this multi-armed bandit, where there are different ways to solve the problem, and are they able to come up with a cohesive optimization algorithm for it. To answer your question directly about whether an agentic AI or multi-agents will solve it, I don't know. Agentic AIs and multi-agents are not, again, magic pills. It is essentially to say that some are good at doing something really well. For example, if you were to say, okay, there are 4 constraints over here. There is food cost. There is transportation cost, that is a concern. Number of students is a concern. And I don't know, maybe miscellaneous something. If you say, okay, I'm going to create agents who are specifically trained at coming up with optimal routes from Bangalore to Chittambaram, then you might say, I will actually ask that agent first, because that is the best option for me to do, so that I don't feed the children less, nor do I do any other shortcuts, obviously. So if you train an agent, the agent might come, and if the agent is really trained well with respect to multiple data points, then it might come and say, you know what, don't take a bus, take a train. It's faster and it's cheaper also. Maybe then you give it to another agent who's trained at identifying the right cheaper menu. Maybe you order it in bulk. Big Basket has this think for 100 people, if you order, they will give you at 50% cost. I'm just randomly making up. So just saying that putting it into multi-agents is not something which you will expect to immediately solve it out of the box unless they are really trained at doing these things.
On the same context, like so in general, right, like to bring in as a real use case. So initially, when Make My Trip or GoIBBO or any other platforms that was introduced, it was only for the travel. Later now, if you see, like it's with they can book the cab, they can provide you the hotel accommodation. It has come up with multiple other things. So one platform providing into a different tangent, travel, accommodation, food, and everything end to end, like cab service, everything. So is it like that is how it is deployed, where the agentic approach, it will talk to or as an independent interface talking to
I
travel.
don't know. I don't know the internal workings of how they have designed it. For basic things, it's a time and distance calculation. So Chidambaram is 245 kilometers from here. If I book a tempo traveler, it gives me a mileage of 5 kilometers per liter of diesel. So for 245 kilometers, I need to put X liters of diesel plus the running cost plus the driver cost is Y. That is more deterministic in nature. There's no rule or there's no machine learning per se. Dynamicity comes in when you have to take into consideration things like real-time traffic. Cabs or tempo travelers are costlier over the weekend because many people will book it. They are cheaper on Monday morning at 8 o'clock. So I don't know whether these platforms use such models to come up with sophisticated predictions. Even then, they don't necessarily have to build an agent orchestration framework to say give the problem to 10 of them, let them all 10 of them solve, and then there will be one master who will collect the inputs, and then that master agent will decide what is the best option to be shown to the user. I don't know. Maybe not. It looks a little far-fetched to say that they will actually use agentic AIs or ML models to do these things, because these are solvable with simple rule-based systems also. Okay. All right. Any other questions on this? Okay. So some flavor of what how the models respond to sort of slightly complex mathematical reasoning models. Now we'll play around a little bit about creativity. Now you can see that models are able to come up with their answers. Some of the answers are absurd. Some of the answers are to the point. Now, is there a way we can influence the creativity of the model? And as someone very rightly said before, models internally use a parameter called temperature. Think of temperature like the available paths a model could take at the end of every reasoning step. So initially I gave an example of think of I am a human. Now, when the first word is uttered, the possibility of the steps that are there in front of me could be about 50 or 100, depending on various English verbs and stuff like that. Now, the temperature, essentially think of it like a guardrail which you can set to the model and say, don't just go wild looking at every possibility that's out here, but limit your range to this. Limit your range to thinking what is the most probable one to happen. So what we will do is we will kind of put temperature to the test and actually see how temperature works. Let's take a smaller model simply because it's faster to run and hopefully it will produce the output. So you can see that on the left there is a slider bar where which I can move the temperature from all the way 0 to 2. So let's give it a hypothetical question. Let's say I'm going to give it this. The question is this: write a one paragraph origin story for a fictional Indian city built on floating islands. Don't ask me why I chose this. It just tries to show you the creative aspects of how far-fetched somebody could think about a description like this. So we are asking in this case 5.3 to come up with a one para story for a origin story. Like how did it happen? Like for a mythical or a fictional Indian city which has been built on top of a floating island. Okay, so let's just ask it. Pay attention to the temperature. The temperature is set to 0. Let's see what it does. Nanda, how are we doing on time?
Lakshmi, we have about 20 minutes.
Okay, all right, yeah. Hopefully we should be okay. Okay, so here's the response. Let me increase my screen size. In the heart of India, where myths intertwine with reality, lies the enchanting city of Aravati. So it's an imaginary name, a marvel that defies all conventional wisdom, blah, 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 blah. So it's come up with a nice, the city was founded centuries ago on an expansive lake that had mysteriously appeared overnight in a region known for its propensity to conjure wonders from thin air. The ingenious architect constructed their floating abodes using lightweight materials with magical properties that allowed them to buoyancy, but also harmony, blah, blah. Okay. Now let's just, for the sake of fun, let's just make the temperature to 2 and ask the same question to the same model. I don't know what it's going to say. This is the first time I'm running this on 5.3. Let's see. If it gives exactly the same answer, then.
So, Lakshmi, meanwhile, a question to you. So the interface UI that you have built, is it available for everyone can fetch it?
Yeah. So.
And also, if you can run, give us a high level how to use it.
So yeah. My GitHub repo is on github.com/slakshnasimhan. Over there, you'll find this thing called Local LLM. This has a README, which has steps to install Ollama. How do you run it? How do you run this code also? Okay.
Yeah, Lakshmi, can you also put it on the chat and the link? That'll be great.
All right. Okay. All right. Okay. Look at this now. So now I have set the temperature to 2. Anyone wants to share their thoughts?
It looks like more of imaginary.
Okay. Hallucinating. Well, the purpose of it was to hallucinate. Like we asked it to come up with a fictional Indian city. So it had to hallucinate. It had to come up with things that does not exist. Any other thoughts?
You asked for one paragraph, but it did like 3 or 4 paragraphs.
Balaji, you are like, okay, you should become a large language model evaluator or somebody. Okay.
I'll become a tester.
Tester. Okay. So, yeah. So basically, related back to what I said before about temperature and what temperature actually does. So if large language models, basically transformer-based models, they are prediction models, which is they are trying to say, hey, what is the next word that is likely to come after this? And the temperature controls the fact that don't look at expansively everything, but look at what is likely to come based on how it will eventually lead. What is the graph that it will eventually lead to? By setting a larger temperature, we are essentially telling it that try and pick things from extremes, try and go to the extreme boundaries of it. So instead of it going linearly, now it started going totally random. And then, but you can see the creativity. You can see that how setting a larger temperature or a higher temperature allows the model to explore embeddings which are actually very far away from the place that it started. It ended up creating a very beautiful story. It was good because it was a fictional one that we wanted, but you can realize that if it was a factual question that we were asking, let's see, let's ask something about, tell me something about what it's, I've not asked this question, I'm just going to ask it and see what it's going to say. LLMs are always stateless, correct? Do not remember even for multiple queries, as far as I know. So there is an element of context memory. So which is why if you are in a conversation with an agent, you ask it one question and then you ask it the next question. For example, you ask it the question of let's why don't we see it in action?
I think, Lakshmi, that are specific to few models. Not all models exhibit the memory and the conversation retention.
Let's say, for example, who scored the final goal in FIFA World? I don't even know the answer to this question, so I'm just going to trust whatever it says. Okay.
So, sir, I just want to know, so let's say I'm giving out data. Let's say the Prime Minister is Rajnath. After I turn it off, I turn it on, it will remember, is it Rajnath or it will change?
No, it will not. Of course, we are not talking about the context of when you shut down the conversation. So final goal of FIFA World Cup 2018. Okay. Okay, who assisted him? Now, this is the context memory, right? Like the first question was who scored the final goal. The next question was who assisted him. So it had to know the context of him was based on the previous question that I asked, which is when it know the assist was provided by Paul Pogba. I don't even know who it's. Yeah, so memory is okay. Let's go back to what was his. Tell me something about Abdul Kalam. So you can see that. So it is actually coming up with a very nice wording. It is undeterred even by unable to primary exams because of color blindness. He wants to. So you can see that it is very expansive. It is actually using very powerful phrases, nice proverbs, words that evoke emotions. And like, for example, after serving the country well over 5 decades, Dr. Abdul Kalam finally saw Indian soil transform into an self-reliant technological hub due to his dedicated scientists' influence on policy making. Like some of it is not actually true, but it's very expansive. It's very, very creative in the words that it comes to. So the point of this was essentially to tell you that one way you can control the output of your large language model is by the temperature. Now, you might ask, how do I set the temperature? Like in many of the LLMs, like ChatGPT and all, I don't have a knob to drag the temperature to the left or the right. So prompting is a way by which you can actually control the output of the model and giving directions to it with respect to temperature. For example, one of the prompts is like, ground your facts on factual data. Do not come up with things that do not exist. Make sure that every response that you give is factually correct. Now, these are literally what the model interprets as the temperature that you are communicating to it to act with. So though we don't explicitly many times set the temperature, the tone and the wordings and the guardrails that you give to a model when it comes to especially prompting internally gets translated into the temperature that the model uses. Okay. All right. So I think we covered both. We tested with some crazy questions. We saw how the models were. We kind of played around with temperatures. We looked at what low temperatures meant, like forced, deterministic, predictable, medium, balanced. High was like very creative and totally, nice responses. I wouldn't say bad for the question that we asked. Okay, some of you talked about, asked me this question, why some LLMs are fast and some are thoughtful. We saw practical examples. We saw DeepSeek, which was like a never-ending conversation. It was just going on and on and on, telling what all it's trying to think about, etc. Some models were very quick, some models were reasonably fast, that they were able to tell you, etc. Now, this all boils down to what we call as the model size, which is measured in terms of the parameters that it has. Parameters is very simply put equivalent to what I told in terms of what are all the possible options that comes after every single step. In this case, step could be a word if it's a language model. If it is a coding model like a copilot, it's what is the next possible syntax, what is the next possible code that has to come. If it is a image generation model, then it's like what's the next possible pixel that has to come after this, etc. So at net, all of these models rely on transformer architecture, which is nothing but a series of neural nets where the weights of the nets are internal associated with either text or image, etc. So larger models have, in theory, have larger cognitive power or various things that it has to evaluate before coming to a final answer. Smaller models are faster, sometimes they could be wrong, etc. And then we also looked about how temperatures can influence the accuracy of the output or the predictability of the output, so to speak. So of the models that we kind of looked at today, so you guys can see the screen. So yeah. So leaving aside Gwen3 coder, which is what I'm still playing around with Claude for me to auto-generate code. You can see in some cases the model size directly is a translation of the parameters. So Llama 3 is actually, I think, a 4 or an 8 billion parameter model. DeepSeek is, in this case, what I have is a 14 billion parameter model, which means that it has more things that it can process, not from a compute perspective, from various options that it can evaluate in its mind, which sometimes can make it very slow also. 5.3 on the other hand is an extremely small model, if I'm right. It's only a 4 billion parameter model, which so it's very small, very fast also.
Lakshmi, time check.
Yeah. Sorry. Yeah, we'll hopefully be, after this, it's all pretty boring. Okay, how do you make your local LLMs work? Yeah. So some of you asked about what do I choose based on what I have. So if you have a laptop like what I have, then generally 7 to 8 billion models are pretty decently okay. If you have a GPU one, then 13, 14 billions are good. If you have a high-end GPU, somebody said they have a 1060 NVIDIA, then probably a high-end models can actually work. They're very good, very strong, but they might take time, etc. Quantized models, we'll talk about how to do quantization, how do you use LoRa, etc., to bring down your model parameters, etc. So generally start with Llama 3 for general use. As you can see, most of the time it's fine, except that it can be cocky and then think everything is right. Gwen or DeepSeek, we also saw how DeepSeek was. It's probably slow, thinking very deeply, etc. Depending on the type of problem that you throw it, it may take time. Sometimes it will come with a very, very good answer. But in this case, for Bangalore thing, it came with a really long answer as well. Okay, how do you do that? Use GPU much faster for various reasons why GPUs are faster. We'll talk about later. RAM, VRAM, important. This laptop has about 16 GB RAM, so it's pretty good. Yeah, don't run too many parallel apps. It just sucks up memory. Avoiding very long conversations is also a great way for you to free up the unwanted memory. Of course, prompts are the powerhouse. How you actually get the better out of it. Be specific, give examples, ask for step-by-step reasoning only when needed. Otherwise, it actually slows down the model. Break it into smaller ones, clear instructions. So instead of saying explain Kubernetes, you say explain Kubernetes like I am junior engineer. Specific to it makes it easier for you to do that. Okay, to check the RAM thing, we'll talk about it later. Okay, some of you asked about RAG. We are not going to cover RAG here, but depending on enthusiasm, a number of people who wanted, we can probably set up something very specific for how do you build your own RAG, how do you run it with your own LLMs, and actually you can build your own conversational bot or your personal assistant, however you want to call it. We can again set up a session on that. It basically RAGs essentially allow you to offload some of the processing from your memory into a disk, in the sense that the RAG tells a specific context of something which is very unique to your system. So the model don't have to, in many of the cases, they don't exhaust out there all the possible spaces that they have to traverse through, but look at the RAG to come up with an answer faster. Oh, sorry. Fine tune, I'm not going to cover it. Fine tune is a separate topic in itself. Much deep dive is needed. Again, sometime for a future session, we'll go over LoRa or QLoRa. Okay, how do you pick a model? I talked about it briefly. If you just need summaries, things, then a smaller 7-8 billion model is fine. If you are deep into math or logic, then go for Gwen or DeepSeek. Again, this is not cast in stone. Generally, kind of works. Tiny models 5, we also saw how 5 works. Chat, Llama 3 is pretty good, right? Like it was able to challenge, very concise, etc. Coding, you need a larger model because the problem space is very wide. And okay, how do you make it work well? Choose the right model. We talked about it. How do you tune? Not just prompts, just free up things, keep memory, etc. Better prompts. Use RAG. What is below it? Okay. When to fine tune, know when to fine tune your model, and then pick the right model for the job. So majority, half of it is about the LLMs, half of it is about the configuration. So both have to go hand in hand for your configuration to work. Okay, important. Remember that if you have a CPU only machine, your LLM could be slow. Memory limits can stifle how fast your LLMs can work. Smaller models hallucinate more. We saw it today. And then if you're going to go for production, you definitely need to fine tune. Out of the box models are like generic things. You have to fine tune them for your use cases. Performance is like wildly different. So remember that you need to test them, etc. Where they really struggle, yes, very long context analysis. We took the problem, and then we saw sometimes it just takes a lot of time. Real-time web search, you have to build plugins and stuff like that to get it to work. Multi-step planning, we also talked about it today. Deep research synthesis, I don't have examples for it, but if you install it, try it out and let me know how it works. Complex legal reasoning is also a space where some different context than just logical things is needed. Large-scale multilingual translation is also an area where local LLMs might have a problem. So remember that even cloud-hosted large language models have a huge GPU power processing them. So sometimes it's very hard to beat their performance, but we also know what's a soft spot for using local LLMs. Okay, when you're switching from cloud, it's generally not very different. What stays the same? Chunking logic, embedding, vector, RAG, all remains the same. Most of the times, it's just this one line that changes that. Instead of calling an inference model on the cloud, you just call a locally running inference model. That's it. Most of the other things just remain the same, nothing to do. Okay. See, Nanda, you told me and I rushed through and I got it done.
Cool. Thanks, Lakshmi, for a wonderful session. I mean, I'm sure that if we have more time, you would have gone even deeper. I would definitely would like to have one more session on the LLM.
Sure, man. You are the one who's doing all the hard work. I'm just coming and talking.
No, not at all. You have investing your time playing around day in, day out, and then sharing that knowledge is commendable.
Thank you for giving me this opportunity. Do we have time for any questions?
If people wants to stay for another 5 minutes, 6 minutes, we can stay here and then take up some questions.
Yeah, I have a question, Lakshmi. I think if the criteria is to run locally, what's your view on running SLMs instead of LLMs?
Absolutely,
why?
yes. Yeah, absolutely, yes. I mean,
why you would recommend, why you would not recommend? Please.
I mean, SLMs require you to train and fine-tune your models, which means that you or someone knows the techniques for building quantization well. So that's definitely a reason for it. The second reason is you have to constantly keep doing it. It's not a one-shot wonder that once you do an optimization or a quantization and it works, it just stays the same. Systems decay, which means newer knowledge has to be again retrained. You again have to do this quantization. You have to measure how well you're able to reduce the lookup space and all of those things. So SLM, we will probably do, if many of you agree, then we'll do one deep dive on how do you build an SLM out of an LLM. We'll take one LLM and then we'll take a use case and see, can we convert this LLM into a small language model, and how do we actually prove it's a small language model? What does small mean? How will we measure the smallness of it while keeping in mind the accuracy of the responses, etc.? So SLMs obviously are great. I don't know what the good example for it could be, man. It's like getting something custom built for your own house versus buying something generic that works in majority of the places, but might have some quirky things for your house. So if you build something custom that's nothing like it, but know that it's custom only for you, it might require maintenance, which might be harder to make. Think of it like you build a custom bench just for your house. It will not fit anywhere else. You fit it only for a specific space. If it breaks, you have to build something all over again. Only some people might know how to tune it and get it to work than buying a generic desk or a bench, which will say mostly fits in majority of use cases. If it does not work, I will change it. It constantly gets upgraded. You have GPT 3, 4, 5. So newer versions keep bringing me the capability out of the box without me having to invest my time to improving them. So it's a trade-off.
Okay.
Thanks, Lakshmi, for the wonderful session. And I'm sure we definitely need one more session to dive a little more, talk about more aspect of it, calling, writing a program and interacting with it. And then small LLM is also one of the interesting topic. You also talked about fine-tuned models. We are eagerly waiting for these upcoming sessions.
Sure, man. We'll plan for something. So,
Okay.
Okay.
Yeah. Thanks, everyone. And this recording will be available on the YouTube. So I have given the link. Please subscribe. And then for future sessions, check out our LinkedIn SaaviGenAI page. We'll be hosting all the events there.
Very
Thanks,
All
everyone.
right.
Thanks
Thank
for
you,
you.
Lakshmi. Thank you,
Thank
Nanda.
you.
Bye-bye. Yeah.
Bye. Yeah.